Hi students, this is Mr. Yao. In this lesson, we are going to review the features and different forms of quadratic functions that we have learned. So first, here's a little diagram to show us how to convert between different forms. We have learned three different forms: standard form, which is f of x equals ax squared plus bx plus c, no parentheses, it's just a standard form in order. Intercept form, f of x equals a times x minus p times x minus q, and the p and the q are going to be p0, q0 are going to be our intercepts. And then we have also learned vertex form, a times x minus h squared plus k, and h comma k is our vertex, which means again h has to be the opposite value when you put inside parentheses. Same thing with the p and the q when you try to put them inside parentheses. So back in 4.9d, we have learned how to convert from standard form to vertex form first. So, actually, how to convert from standard form to intercept form. We're gonna factor, but don't forget, eventually you also need to make sure it's going to get into x in both the parentheses so that you can have an a in the front. As for from standard form to vertex form, we're going to need to find the negative b over 2a so that you can actually use that as your h and then plug it in to find your k and eventually write it as a times x minus h squared plus k. And then from intercept form to standard form or from vertex form to standard form is the same. We are going to distribute and simplify. So when you distribute, make sure the a only goes into the x, the first parentheses. That a is going to be with ax and the a and p. And this one, we have a square, make sure you write it twice, and then do the same thing as intercept form. Also, don't forget there's a plus k on the end. And then we have also learned to convert from intercept form to vertex form. Of course, you can convert from intercept form to standard form and then to vertex form, but that's going to take a bit longer. Instead, we're going to do p plus q over 2 as our h, because again, when you have a quadratic graph, the p and the q, they're basically on equidistant to the vertex, or they're actually symmetric to each other when you have this line of symmetry. And that is why we can just find the average of these two values, and that's going to be the x-coordinate for our vertex, which is h. And then you're going to plug it in to find k, eventually write it as a times x minus h squared plus k. Lastly, from vertex form to standard form, unfortunately, that one doesn't have a shortcut, so you do need to change it to standard form first, and then from standard form do factoring to convert into intercept form. Now let's go through a few examples. First one, find zeros and vertex. We did learn about zeros. We try to find zeros, we're going to set it equal to 0 and then solve the equations. The solutions would be the zeros. So for this one, you have -3, 6, and 24. You can for sure factor out the GCF, which is -3. Then you're left with an x squared minus 2x minus 8 equals 0. Okay, it's just an x squared, so you can easily factor -3 and then x minus 4 times x plus 2, which means your zeros are going to be a 4 from the first parentheses and a -2 from the second parentheses. And now, after you factor, we can also easily write, because finding the zeros can actually get us to the intercept form pretty easily. In this case, we don't even have to divide anything in both parentheses because we already have just an x, which means the intercept form will just be a -3 in the front, which is our a, and then it's x minus 4 times x plus 2. There you go. And now you have the intercept form, or you can easily find a vertex from there, or you can still do your h equals -b over 2a, which will be a negative sign in the front. My b is a 6. My 2a is a 2 times -3, so it's actually a 6 over -6, but there's a negative sign in the front, which is a 1. And you know what? Let's also use the p and q to check, since we have actually found our intercept form. So our p is a 4, our q is a -2, which means our h is p plus q, so let me write it down, p plus q over 2, which is 4 plus -2 over 2. That's a 2 on the top over 2. It's still a 1. So you see, no matter which method you use, -b over 2a or p plus q over 2, you're going to find the same thing. H is 1. And now we can actually plug it in to find the k, which is f of 1, negative 3 in the front, then it's 1 squared plus 6 times 1 plus 24. It's a negative 3 plus 6, which is a positive 3 plus 24, it's a 27. And now that means we can also write the vertex. So I know the example didn't ask, but we might as well just practice. So f of x is negative 3 is our a. Don't forget the h is going to be the opposite when you put it inside parentheses, so it's x minus 1 squared, eventually. On the end, a plus k, which is a plus 20, positive 27. There you go. Now we have the intercept form and the vertex form. Example 2. Let's do the same thing. Let's practice the same thing. Set it equal to 0. And we are finding the zeros. So we have, but in this case, 4, 5. Well, we can't actually find a combination that can multiply to get a negative 20 and adds up to a 3. There's no such thing. That means we have to use either completeness square or quadratic formula. In this case, let's use the quadratic formula. My a is a 4, my b is a 3, and my c is a negative 5. So that means my quadratic formula, negative b. Well, let me actually find a discriminant first. 3 squared minus 4 times negative 5. It's a 9 in the front. 4 times 4 is an 80. 16 times negative 5 is an 80. But it's subtracting a negative 80. So it's going to be plus 80. It's 89. Quadratic formula, negative b is a negative 3 plus minus square root of 89 all over 2a. 2a is 2 times 4. So we actually have the two zeros as negative. Well, that's actually an 8 on the bottom. So it's a negative 3 over 8 plus square root of 89 over 8. Or the other one is a negative 3 over 8 minus square root of 89 over 8. Hey, let's still say we want to well, they are both real numbers, even though you have radical. That just means they're irrational, but they're still real numbers, so they're still the real zeros. Let's say you still want to rewrite it into a factored or intercept form. Well, let's try it. It's going to be a 4 in the front. Inside the parentheses, you're going to need to subtract these zeros. So it's actually going to be an x minus my negative 3a plus square root of 89 over 8. That's the first parentheses. Then the second one is x minus negative 3/8 minus square root of 89 over 9. Now I can actually try to get rid of the inside parentheses. We are going to end up with 4 in the front. That's a negative, subtracting a negative 3/8, so it's x plus 3/8, and it's a minus square root of 89 over 8. And then it's an x plus 3/8 plus square root of 89 over 9. And that is the intercept form. I know it looks complicated, but you just have to remember it's x minus p and x minus q. So after you get the p and the q, you need to subtract them and make them put them in the parentheses before you subtract. Next, let's find the h. H is going to be negative b over 2a, which is, well, let me actually use a different color. H is negative b over 2a. So we have a negative. 3 on the top is our b. 2 times 4 is our 2a. So we have a negative 8 over 3. 3 over 8. Now, even if you haven't noticed, let's quickly have a look. Negative 3 over 8 is right here and right here. Negative 3/8. Well, it's because, again, the vertex is actually in between the two intercepts. So let's say these are two intercepts. The vertex is going to be right in the middle, and that is our negative 3/8. The reason we have a plus square root of 89 over 8 is actually adding a square root of 89 over 8 on that direction, on the right side, and then subtracting a square root of 89 over 8, so that we can actually get from the middle to the two x-intercepts. So that's why it's a 1 positive and 1 negative, since you're going right and left. But the same number in the front, negative 3/8, that is our negative b over 2a, which is actually our h. Okay, now let's actually plug it in to find our k. So k is going to be f of negative 3/8, okay, which is going to be a 4 times negative 3/8 squared plus 3 times negative 3/8, then minus 5 on the end. That's going to give us a 4 times 9 over 64, so it's a 9 over 16, then minus a 9 over 8, minus 5. So it's a negative 9 over 16 minus 5, which is going to be a negative 89 over 16. And if you remember, k was supposed to be 4ac minus b squared over 4a. Let's confirm. You see, you already found this 89. 89 is right here. That is our discriminant, which is the 4ac minus b squared. But since our discriminant was b squared minus 4ac, that's why you have a negative in front. The a was a 4, so it's actually an over 16. There you go. So you see everything is like very much connected. Now we can write the vertex form. Vertex form, just as practice. F of x equals, it's a 4 in the front, then it's an x plus 3/8 squared at the end, minus 89 over 16. There you go. That's example 2. Moving on. Rewrite from that function into vertex form. Right now it's intercept form, so let's identify our intercepts. P is, remember, it's going to be the opposite number from what you see inside the parentheses. So P is 4/5, and Q is a negative 2/3, which means our H is going to be P plus Q over 2 to the 4/5 plus a negative 2/3 all over 2. Well, you can put in your calculator, or on the top is going to be a 12 over 15. So you can find a common denominator, which is 15, then minus 10 over 15 all over 2. So on the top, you're left with a 2 over 15 divided by 2 is a 1/15. That is our H. Now let's find our K, which is going to be plugging in the 1/15. We got a negative 2 in the front. It's a 1/15 minus 4/5 and a 1/15 plus a 2/3. And I've showed you in the previous lesson that these two numbers are always just going to be opposites of each other because that represents the distance from the vertex. So let's have a look. Negative 2, 1/15 minus 4/5, which is 12/15, is going to be a negative 11 over 15, which means the next number has to be a positive 11 over 15. When you check, 2/3 is a 10 over 15 plus 1. Well, it is 11 over 15. Now we can multiply everything together. Negative, negative, so it's a positive. On the top is 11 times 11, which is 121 times 2, 242. On the bottom, 225. So our vertex form is going to be, don't forget the leading coefficient, negative 2 times x. Well, h is going to be the opposite, so it's minus 1/15, and then squared plus 242 over 225. Okay, example 4. You have intercept form, it's into standard form. Standard form, again, is when you have no parentheses. So we are going to multiply. Multiply. That part gives us a 6x minus 6 times 2, negative 2/3 is going to be a 4. Then an x plus, you can either do the string or you can draw your box. 6x, negative 4, and we have x and a 1. 6x times x is 6x squared. Negative 4 times x is negative 4x. 6x times 1 is a 6x. Eventually, 1 times negative 4 is a negative 4. Oh, our standard form is going to be 6x squared, 6x and negative 4x, so 2x, and eventually a minus 4. And that's example 4. And that's a quick review on features and different forms of quadratic functions that we have learned. Thank you.